So far, we have talked about probability mostly in terms of events. So, for example, we might ask whether a die roll is even, whether two dice add up to 7, or whether a poker hand is a full house. But often we want to measure something numerical from the experiment. So, for example, if we toss coins, we may care about the number of heads. If we roll dice, we may care about the total number of points we get. If we send data through a noisy channel, we may care about the number of errors and so on. So many problems are related to this. So instead of only asking whether an event happened, we want a way to assign a number to each possible outcome. And that is what a random variable does. So essentially, a random variable turns the outcome of a random experiment into a number, right? So here is the formal definition. So a random variable is a function from the sample space to the real numbers. So if the sample space is this big omega here, then a random variable is just going to be a function that goes from the sample space into R here. The word random can be a little misleading here, actually. The idea being that the function x is not changing randomly. This is not a random thing. The x is actually just a function. What is random is the outcome from the sample space, right? So the function is going to take something from the sample space, and what's going to be random is what you're going to end up with the outcome, right? So once the outcome is known, then the value of x of that outcome is going to be a number. So a good way to think about a random variable is it's a measurement of the outcome. So it takes a possibly complicated outcome and records the numerical information that we care about. And I think the easiest way to see this is with a simple example. So here, let's say the experiment is tossing a fair coin 3 times. So what is the sample space? It's going to be all the possibilities. So you can have heads, 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 tail, heads, tail, heads, and so on. Let's define the random variable x to be the number of heads obtained. So again, the random variable x here, the big X, it's going to be a function from this space here to the real numbers. And so in our case, that function is going to just count the number of heads in whatever sample we have. So for example, if our sample is heads, heads, tails, then the number of heads is going to be equal to 2. So this function, when you compute x of head, heads, tails, you should get 2. Heads of tails, tail, heads, you should get a 1, because there's only 1 heads there. A x of tails, tails, tails will then be 0, because there are no heads over here. And so the random variable, it essentially, another way to think about it, it doesn't remember the whole outcome itself. It just gives you the number that you're interested in. So like, for example, if you have x, like we said here, of heads, heads, tails, this is going to be the same as x of heads, tail, heads, and it's going to be the same of x of tails, heads, heads. And so all 3 of them, the random variable will give you 2. And so in some sense, this function, the output of the function forgets what is going on inside. So in this case, it's essentially, it's not an injective function in this case. So you have different inputs with the same output, right? And so essentially the random variable is sort of forgetting a bit about what's happening, but only remembering the thing that you are interested in, right? And then you can deal with the thing of interest, right? So let's introduce the notation we use for probabilities involving random variables. So this is the common notation. You write it, the probability of this random variable x equal to small x, right? And this denotes the probability that the random variable x takes the value small x. So formally, you can just write it like this. So the probability that the random variable x is equal to small x is going to be what is the probability of all the events where when you applied the function to it, you get small x. So in our previous example, for example, if we compute, well, what's the probability that x is equal to 2, and here x is the number of heads, right? So it's going to be the probability of all, how do you say, the events that have 2 heads. So this is going to be, so what are the events that have 2 heads? So heads, heads, tails, heads, tail, heads, and tail, heads, heads. So this here is precisely this set over here. It's all the events, so 3 of them in this case, such that when you apply the random variable to them, so when you compute x of any of these 3, you get this number over here, this number 2. And so now what's the probability of these 3 occurring? Well, they are 3 events, and the total space is 8, right? And so the probability is 3 over 8.